Class 9, we are going to start a video lesson for the topic upthrust in fluids, also Archimedes principle and flotation. So before we actually begin with the topic, let us try to understand what the meaning of upthrust is by giving a look at a video. So you can see in this video that we have a plastic mug and we are going to put this plastic mug in water inside a tank. And when we let go of the plastic mug inside water, okay, what happens is this plastic mug is readily pushed in the upward direction. We'll try again. So plastic mug, it is readily pushed in the upward direction with some force. Now remember, this upward push that we feel, that the plastic mug in this example feels when it is put inside water, is what is called upthrust. This is what is called upthrust. Remember, this phenomenon is what is called upthrust. Now, upthrust is not just true in case of a liquid. It is in case of any fluid, remember. In case of air also, air also exerts, so to say, something called an upthrust. So, upthrust is a phenomenon which is true for any fluid, be it water, be it any other liquid, or for that matter, it is also true for air. Air also exerts upthrust, because of which, if we have a hydrogen-filled balloon, what happens is this balloon will be, we have a balloon, this balloon will go on rising up in air, because the air is exerting upthrust on this balloon. Hydrogen being lighter than air, hydrogen having density lesser than air, so therefore it goes on rising up. The same is true in case of that plastic mug. The plastic mug has density. The plastic mug has density lesser than that of water, so therefore it rises up. It experiences, it is the upthrust that pushes the plastic mug up. Okay, now this upthrust also has another name. This upthrust is also called buoyant force. B-U-O-Y-A-N-T. This upward push that a body experiences when it is placed in a fluid, when it is submerged in a fluid, is what is called upthrust, or also called buoyant force, remember. And this phenomenon of a body being pushed up, or a body experiencing an upward push when placed in a fluid, is what is called buoyancy. Okay, so that is what is called buoyancy, and the force itself is called upthrust. The force with which a body is pushed up in a fluid is what is called upthrust or buoyant force, as you can see. And the symbol that we generally use for buoyant force is F with a subscript capital B. So FB, as you can see written in here. So this is the introduction to upthrust. So some examples of upthrust: pushing an empty can into water, like we did in our experiment. Okay, pushing a cork in water. Okay, cork is a very light wooden kind of a material. Let me try showing you that. So this is the picture of a cork, as you can see. This is the picture of this is a cork. Okay, that's a cork. All right, it is generally made up of the outside portion, the outside layer of bark of a specific tree. Okay, so this is cork, and its density is lesser than that of water. So cork also, when you put cork in water, what happens is a cork gets pushed up in water. Pushing a cork in water, that is exactly what this thing is talking about. Okay, so that is generally true. We saw the plastic mug being pushed up. Likewise, a cork is pushed up in water when placed in water. So that is because of upthrust. Now, the note over here says, like liquids, gases also have property of buoyancy. Okay, so all fluids, they offer something called buoyant force or upthrust. Now, let us look at the condition for a body to float or sink in a fluid. Now, you all have studied this before also. If we have say a liquid, most general liquid is water. So let us talk about water in here. So we have water in a vessel, and we have a body, this body over here, as shown in the picture. Now if the weight of the body is greater than the upthrust, if the weight of the body is greater than the upthrust. Now this condition can also be said in another way. In other words, we can say if the density of the body is greater than the density of water. Okay, so if the density of the body is greater than density of water, or if the weight of the body is greater than the upthrust, then what happens is the body will sink. Okay, so which is shown in condition 2 over here. So if the weight of the body, as you can see, is greater than the upthrust, okay, which in other words can be expressed this way: if the density of the body is greater than density of water, what happens is the body will sink. So in this case, what happens is the body will sink. Whereas if the weight of the body is equal to the upthrust, or the weight of the body is lesser than the upthrust, in both of these two cases, the body will float, remember. In both of these two cases, the body will float. Now, if the weight of the body is equal to the upthrust, the body will float as shown in this picture. Okay, in this fashion, it will float such that the whole of the body is completely submerged underwater, is completely under the surface of water, as you can see in this picture. Okay, but still it is floating. Whereas if it is this case, where the weight of the body is lesser than the upthrust, then if this is your liquid, okay, this is your liquid, then the body will float in this fashion, such that only some portion of the body is underwater. The other remaining half of the body will be above the surface of water. So this picture is true for this case, this picture is true for this case, and this picture is true if the weight of the body is equal to the upthrust. So these are the conditions we discussed for a body to float or sink in a liquid or in any fluid. This is also true for air, remember. Now let us look at the characteristic properties of upthrust. First of all, larger the volume of a body submerged in a fluid, greater is the upthrust. Okay, so bigger the volume of a body, so we have a big plastic mug, say for example, and a small plastic mug. Okay, both of them are submerged on the same liquid, say water. So what happens is, this plastic mug, both are made up of plastic, but since this plastic mug has a bigger volume, so this one experiences a greater upthrust than this one. So let me call this FB2 and FB1. FB1 is the upthrust experienced by this bigger plastic mug, and FB2 is the upthrust experienced by the smaller plastic mug. So FB1, the upthrust experienced by the body having bigger volume, is greater than FB2. Okay, so as the example given in the book says, if we have feather and we have a small pebble, say for example, and we let both of them fall through air. So we have feather, a bunch of feathers, and pebble exactly of the same mass. Okay, feather and pebble of the same mass. What happens is the pebble will fall very quickly, whereas the feather, okay, I don't know how to draw the feather, so the feather, alright, falls very slowly through air. Why? Because the feather has a bigger volume compared to this pebble, and the feather experiences a greater upthrust, remember. So this is one very, very important property or characteristic of upthrust, that is, bigger the volume of a body, more is the upthrust it experiences. Okay, you can try it with a blade also. If we have a blade, all right, so we have a blade. Okay, so this blade, if you place it vertically you place the blade such that its sharp edges are cutting through water. The sharp edges of the blade are cutting through water. You place it in water. Okay, then what happens? This blade simply falls down, falls through the water. Why? Because this blade, a small volume of the blade, a very small volume of the blade, that is a sharp edge, is falling through the fluid. Okay, whereas the blade, if placed flat on the water, when you place the blade flat on the water, okay, so the blade is placed flat on water. All right, so this is your water, this is a vessel. Okay, so what happens is this blade experiences more upward push, more upthrust, because its bigger volume is facing water. More volume of it is facing the surface of water. So therefore, since it has a bigger volume now, this body has a bigger volume now, so therefore it experiences more upthrust, remember. So bigger the volume of the body, more is the upthrust it experiences. So this is one important characteristic, like I already said, that of upthrust. Now the second characteristic is, for same volume inside the fluid, more the density of the fluid, greater is the upthrust. So if we have the same plastic mug, say for example, equal sized, identical plastic mugs, doesn't look identical in my picture of course. Okay, now if this plastic mug or this body is placed in water, and the other plastic mug, the body is placed in mercury. Mercury is the only liquid metal, remember. It's a very, very dense, highly dense liquid. So what happens is, naturally this body will be pushed upward, will experience more upthrust or more buoyant force when placed in mercury. Whereas in water, it of course experiences upthrust, but much lesser. The upthrust is much lesser than that it experiences in case of mercury, remember. So greater the density of the liquid, upthrust also therefore depends on the density of the liquid. More is the density of the liquid, more is the upthrust it experiences. And finally, the upthrust acts on the body in upward direction at the center of buoyancy. That is the center of gravity of the displaced fluid. Okay. Remember one thing, whenever we have a liquid, okay, water we have, say for example, whenever we place a body on the liquid, what happens is, say for example, the body is floating, okay, the weight of the body is lesser than the upthrust it experiences, so the body floats. What happens is, although the body may be floating, whenever we place some body, be it the body sinking in water or be the body floating on water, what happens is, be it floating on water like I said, or it's sinking in water, what happens is, so whenever we place a body in a liquid, some portion of the liquid rises up. Some portion of the liquid, this is its initial surface, blue line is the initial surface. Okay, now the black line that I have drawn over here is the new surface when we place the body in water. Okay, like I said, the body may be sinking in water, but still some portion of the body of the liquid will rise up. Now this amount, I'm showing it by red now. So this amount of the liquid is what is called the displaced liquid, because it is displaced from its original position. Okay, if the vessel was already completely filled up, when we place the body in the liquid, what happens is, the liquid will come out of the body, will spill out of the body. So that is the displaced liquid, remember. Initially, like I said, if the body was not completely filled up, then the liquid level will rise up. So that is what is called the displaced liquid, remember. And let me now itself at the very beginning tell you, the displaced liquid, the weight of the displaced liquid, in fact, the weight of the displaced liquid is equal to the weight, I'm writing WT for weight, okay, is equal to the weight of the submerged part of the body. Submerged part of the body. So this much part of the body is submerged, so that the body has some weight. Okay, so that part of the body has some weight. Alright, so the weight of the body is equal to the submerged part, the weight of the displaced liquid. So this is the displaced liquid. So weight of the displaced liquid is equal to the weight of the submerged part of the body. Remember that. Keep that thing in mind for now. Alright, so What the third characteristic of upthrust is telling us is that the upthrust acts. Where is the, so we have the body here. So this is the liquid, okay, and this is the body here. So it is submerged. This part is submerged. This part of the body is submerged. Okay. So where is the upthrust acting? This characteristic talks about at what point the upthrust is acting. So the upthrust always acts, remember, at a point called the center of buoyancy. Center of buoyancy. What is the center of buoyancy? Center of buoyancy. So if this part of the body is submerged underwater, and the blue part is the part of the body above water. So black line is the water surface. So center of buoyancy is the center of the submerged part of the body, remember. So the green part is the submerged part of the body. So the center, exact center or geometric center of the submerged part of the body is this. So that point is called the center of buoyancy, remember. So if a body is floating this way, the upthrust will be acting at the center of buoyancy. Whereas if the body is completely submerged underwater, so if the body is completely underwater, be it floating or completely sinking at the bottom, okay, be the body at the bottom of the vessel, the upthrust will be acting at the center of gravity of the body. If the body is completely submerged, then center of buoyancy, this point, and the center of gravity are one and the same point. Whereas if the body is only half submerged, okay, some part of the body is submerged, then the upthrust is acting at the center of buoyancy of the body. So these are the characteristics of the force called buoyant force or the upthrust.